So I've been just kind of a quick rundown on me. I've been a Unix sysadministrator since '97. We started, when I started, it was all Sun Solaris. There were a couple of HPs, but in all honesty, it was a completely Sun Solaris shop. And I'd been running Linux at home. Like I remember my first Linux install was Slackware with kernel 1.2.13. So I've been playing with Linux for a long time. It was in the early 2000s that we first brought in Linux, and there were kind of little stealth, anyone else at companies have probably had, there were little stealth Linux machines that showed up. We didn't actually get any official support until one of our EDA tool vendors actually told one of our VPs, "You're crazy if you're running our tool on Spark, you're wasting your money." That's what finally got us backing. And to clarify, I actually support the chip designers, the hardware designers at Qualcomm, so it's all the EDA compute. And initially when we started with Linux, we started with, we built our own image, and I won't say which distribution was, you can probably guess which one it was at the time. But nobody actually really had an enterprise Linux at the time. Then when they switched to enterprise Linux was the same point that SUSE was bought by Novell, and they actually came to us and wanted to work with us and were willing to work with us, which was a big plus. And that's when we started using SUSE in the hardware side of our compute farm, and we've been using them ever since as our primary compute. And one of the nice things about SUSE was they wanted to work with us and with the ISVs to get the tools certified on SUSE, whereas the other vendor would just say, "We're the one everyone's certified on, so you have to buy us." So it was nice to have some competition. And since, like I said, we've been using them since then. I didn't hook up the remote. Oop, my slides got changed. So I already went over some of this. Oop. And I apologize in advance. My slides are actually pretty wordy because it's all pretty technical info. When x86-64 came out, that was when those first enterprise really about the same amount of time. And part of the draw with SUSE was they wanted to license the operating system. And they actually saw a difference between licensing the operating system and the support, whereas the other vendor had, here's the box, they both come together, and there was no working on the price. So that was kind of a stopper for us. And I guess I actually kind of already went over all, so I can't see it from here. Oh, thanks. Yeah. So the probably half of this is going to be about the auto mounter, because the auto mounter was, for at least a decade, was probably the bane of our existence. It was the buggiest thing. Anyone who's ever worked with Solaris and with Linux probably knows that the auto mounter on Solaris is pretty good, and the auto mounter on Linux for a very long time was horrible. So that is probably the single biggest program that has opened the most cases with SUSE at this point for us. And as part of the partnership, one of the things with SUSE is, and we've gotten feedback from them, is that we don't open a case with them unless we've already done a ton of due diligence. We give them support configs, we give them kernel dumps, we give them core dumps and everything. We don't just go, hey, this thing broke. We don't open level 1 tickets. We jump straight to the higher tiers and hand them gigs sometimes worth of data to dig from. So we've gotten feedback that really helps them get started. They can go straight to engineering. So if you don't mind, next one. And then now that was kind of the start of our relationship. Now we're going to talk about, if you go now, like I said, the first big chunk is going to be the auto mounter. So this was in the beginning. You can go to the next one. Oh, go back just one. Yeah. So before AutoFS 4 came out, we were actually running on, I believe it was 3.1.4. This was at a period of time where no one had been maintaining the auto mounter for some time. That auto mounter had no direct map support, and we had a direct map on Solaris that had been working for over a decade. It had a lot of paths in it. We have pretty large paths. I actually don't know the number anymore, but it's pretty big. And the engineers were used to all the paths to their projects. And we were basically told, hey, if we're going to work on Linux, and since it's Unix, we're not going to change anything. We know if it's the same path on Solaris, we need the same path on Linux. we did some digging, and actually one of my coworkers years ago, he actually figured out you could sort of do direct maps by using the map was a shell script. And when you pass down paths, it would call the shell script with the path name to the point you were. It would read the actual map. If it was a path, it would call mount and you were good. If it didn't exist at all, it just told the auto-mounter that's not a real path. If it was still an existing path but not a mount path, it was still a submount, it would actually call the auto-mounter saying, hey, here's the next level, and it ran another daemon and called it with the shell program and would just keep going down. This had a lot of problems because every path that was traversed, you had like a daemon for every single submount. And this was back in the days, I'm sure anyone who's run Linux for a long time remembers if you OOM the box, the killer was not very, it would just kill whoever the last daemon that asked for memory was. So we had a lot of issues with an auto-mounter crashing. And actually, before we get to that, one other issue we ran into around the same time was the argmax. I don't know how, most people don't seem to know about this. If you run getconf and then all caps arg_max, that's the amount of memory that can have all of your environment variables and all your command line flags and things. At the time, Solaris was 2 megabytes by default. Linux was hard-coded to 128K. And because these engineers were used to these very long paths that we used on Linux, or on Solaris, and they would use them, they would set a bunch of variables and reuse these variables again and again and again and again that would get sourced over and over again. They started running over this max limit. And we actually, one of the guys figured out if at the time we had a very long path where the auto-mounter map started, but we also had a very short symlink. And if they changed that long path to the symlink, their memory usage shrunk enough that they made it under that 128K, and their problem essentially went away for a time. Of course, the nice thing now is that is by default is actually now 2 meg on Linux as well. In fact, it's 1/4 the stack, I believe it is, so you can actually bump it up if you want. So it's something different today. For the shell map problem, I have an example. Yeah, go ahead, thanks. So I showed an example of, I created I took a machine, I basically took our maps, I changed names so there's no information, but I randomly mounted 100 paths, or more than 100, I did 110, and I showed just a few, and you can see how just going down, the bottom entry here is the last sub-mount before directories start mounting, but you can see how every single level has a new auto-mount daemon spawned for it. And in the next one, I actually I kind of simulate an OOM killing one. I picked one at random and I killed it. And from that point on, anything from that directory down, that didn't already have a daemon for it, you can now no longer access. This was the biggest problem we ran into. We had to reboot machines constantly because one auto-mount daemon would get killed. They could no longer get to these paths. And if you actually look in mount, the mount entry for that submount is still there with the PID that I killed. So I killed 23543, and you can still see there's a line that says 23543 NFS foobar. And I believe you could theoretically unmount everything, which basically means everything has to stop anyway, but it's just easier to reboot the machine. So that was our solution, was to reboot machines. When they got to this point, we would close a machine from getting jobs, wait till the jobs were gone, reboot the machine, open it back up. And then it was, when AutoFS 4 came out, it was actually a huge improvement over AutoFS 3. It actually had some early direct map support. Early on, there were some interesting bugs. Our original paths were like this use a local NFS. The interesting thing was when you first fed that into it, the logic said that the least common denominator is user, and it remounted user as an auto-mounter path. That obviously doesn't work very well. That broke the entire system. So we had to stop doing that. So what we actually had to do was on the Linux systems was we took the maps from the long path and we used that short path that was a symlink, and we reversed the symlink on Linux. So the Solaris paths had one directory tree and a link to it, and we flipped it on Linux was the easiest way to get around the problem. And actually to this day, we still do that, even though AutoFS 5 will work with the longer path. We figured, why go back again? We already did it. And then a few years ago, we were running into some more bugs with our file maps were getting large. So we actually migrated to LDAP. And we were seeing some very interesting bugs. This rare one I mentioned on the bottom where you would have two mount points under a directory. Somehow one of them would get mounted on the actual sub-mount point. Now we were never able to recreate this. I found it on a few dozen machines. They always were up for at least a month. But no matter how many times we tried to cause it to happen, we could never cause it to happen. Interestingly, that only happened when it was a file map. That was one of the drivers to go to LDAP. Was not only were there more bug fixes at the time, all of the fixes seemed to be aimed at LDAP. And we actually Deke reminded me, one of my coworkers, we actually had a conference call at one point with the SUSE guys and actually Ian Kent, who was the maintainer at the time, who mentioned that LDAP has a slight speed advantage when you actually do a mount. If you're using file maps, the auto-mounter has to reparse the file to get the actual mount point in case it's changed since it was first read in, whereas with LDAP, it just has to do a query. So it's a quick lookup when you use LDAP. So you can go to the next one, thanks. And then when AutoFS 5 came out, things got a lot better. And the thing is, AutoMounter had been such a problem for so long that it was the default thing blamed. It didn't, if a user had any error that said anything about reading a file, they would say, oh, the AutoMounter's broken. The key would be, AutoMounter broke again, would be their ticket. Even if we also use AFS as a file system, the file could be an AFS and they would blame the AutoMounter. We'd try to explain it has nothing to do with that, they didn't care. And now a couple of examples of bugs that SUSE has fixed since then, or over the last few years. We had some interesting cases where the direct mount, for some reason it would just stop expiring direct mounts. It would still expire indirect mounts, it would still mount new direct mounts, it would just never bother to expire direct mounts. Which obviously over time you start just building up more and more mounts. More mounts means there's more problems with NFS, possible NFS hangs. They actually did a pretty good job catching that one. We rarely had one where the auto mount, the NFS path would be gone, but it did not, the auto mounter thought it was there. And if you checked in the syslog, the last entry you would see was that it mounted, but it wouldn't show up in mount anymore. That one was also pretty rare, but that one was fixed. One of the things, actually, this isn't technically a bug, but one of the things you have to remember if you're using, whether you're using LDAP or files, every time you kick a reread, it has to dump the entire, it checks, basically it parses the entire map, looks for anything that's missing, then kind of reverses that and looks for anything that's not in the map anymore that it can then unmount as an auto-mounted entry. Which leads into, if you have really large direct maps, you run into lots of problems that people that don't have large maps never even think about. And we have very large maps. So one of the biggest issues, like performance, the default timeout for the auto-mounter mount, for NFS mounts from the auto-mounter is 10 minutes. If you read through the documentation and actually I'm not even 100% sure it's in the documentation, but I know I read it somewhere, and we finally found out that whatever the timeout is, 1/4 of that time, it will wake up, it will essentially look at all of the NFS mounts and see if they're busy and if mounts can be unmounted or not. So if you have huge maps and you leave that default 10-minute timeout, every 2.5 minutes it wakes up, scans everything, and then finally goes back to sleep. With the size of our maps, we were having issues where at that default timeout, the CPU would be at 100% for several minutes, every few minutes. So that was obviously bad. So over time, we tried different defaults. We tried a couple days at one point. That was a little too long. We actually switched to 4 hours as our default. That tends to be long enough. One of the issues we have is user's job will land on a machine. It will often touch a whole bunch of different directories that will mount, but then it won't use any of them, or just one or two until longer in the run. Then it will finally put output or use another file. And we found that 4 hours was a decent time so that most of those jobs would not need to cause a mount to get to that path. It would still be there. But once jobs were gone or idle, the path would then be unmounted safely. That's why that line was on the last slide. It was supposed to be on this slide. I left it on this slide. Every reread is a full dump of the maps that are configured in the AutoMaster. Sorry about that. So I thought I'd mention, there's a couple basically audit scripts I wrote over time. One of the, or issues that we've run into, we had we had an issue where the older AutoMounter had too many open file descriptors. And this was another one of those, if you hit that limit, AutoMounter was essentially broken. You really had to reboot the machine. Couldn't really fix it manually. That's one of the, SUSE fixed that one. I think that one took a long time to narrow down, but that one's been fixed. We haven't had that one in a long time. Nested mounts is a problem we run into a lot. Just if it's not nested, is, you know, if you've got a certain path name and you have another path with the exact same name, you cannot do that. You cannot have keys that overlap. Unfortunately, even AutoFS 5 has problems with that. So over the years, we have actually had to change to a system that enforces, we have basically seatbelts in place, because when files are edited by hand, people make mistakes. We've also, over the years, because since we were having to put seatbelts for this problem, we've also put in seatbelts for just spelling mistakes. We used to have a ton of paths, instead of no quota, said no coda without a U, you know, silly little typing mistakes. So we put in things to fix those. Users don't have, or the sysadmins that work on that, the file maps don't have to know that stuff. It's just a selection list now. And anytime you hit nested mounts, you usually had to either reboot it, or those, sometimes I was able to clear them. If you can get both of the auto-mount cache entries out of the map and kick a reread, that will actually continue okay. So those you could usually recover from, but you had to hit every single host. So that was a pain. And so when we had some of these problems, we actually wrote audits to watch for these things and to try to catch them and fix them if possible. So like they said, mentioned the direct mounts not responding. So that was 11.4 used to have an issue with that. And so we actually, I think we actually left this in place even though it doesn't need to be there. We watch, if there are several hundred NFS mounts, we start to think, it's a little more than we probably need at one time. So it sends a SIG user 1, which is the signal to AutoMount to go ahead and expire now. And the interesting thing is, anytime, even when the bug was there, if you signaled a user 1 and caused it to expire, it's almost like something knocked on the AutoMounter daemon's head, and from that point on, it's like it would finally go, oh, I'm supposed to go expire these, and it would start expiring them again. So that was kind of a fix until it was actually fixed in the code. This is one of those things that, to this point, we have not seen in our testing on SLES 12, although we haven't done a whole lot of testing. At this point, unfortunately, we're still like 95% SLES 11 SP4. So when you support EDA engineers, the enterprise Linux is, you know, tries to go at a slow pace for the vendors, and then the vendors are slow, and then the engineers are even slower than that. So we're way behind the curve for a lot of people here, but we are doing testing with 12. I actually also wrote an audit for the vanished mounts issue, the one I mentioned, and I had to write this horrible script that actually parsed syslog, looked for every path that said it was mounted. If it wasn't in the mount table and it didn't find an entry that said it expired, then it knew something was wrong and it needed to go kick the AutoMounter. And if you, at that point, I would actually have to do a U-mount of the AutoMount cache entry and then kick a reread would actually get it back, and then you could LS the path and it would show up again, because the AutoMounter actually thought it was mounted. That was an interesting one. That one I have also not seen on 12, and it actually really hasn't been a problem on 11. This one's actually turned off. This audit doesn't exist anymore. This one is another audit we had to deal with. This was an interesting bug we've been working with SUSE on. And I don't think to date, we have not been able to reproduce this, but this was an interesting, it's not technically AutoMounter, but it's NFS. Users' jobs would suddenly show that their current working directory was deleted. And most jobs, if you S-trace them, they would be stuck in a really tight, they would be doing an infinite call of a getEnt, getting back enoent, and they would just infinitely do that. Except for a very tiny amount of tools, if they linked against the Boost C++ libraries, those would crash. So obviously that was a bad thing. Thankfully, there were very few tools that used that. The bizarre thing about this was I was able to write an audit because if you knew that their directory was supposed to be there and any other process outside of that one that was stuck did an ls of the same directory, it's like something in the VFS layer would wake up and the path would magically reappear, and their stuck process would continue to process from that point on. That's one of the most bizarre bugs I've ever seen. So it's another very ugly shell script that basically does a find, and it does proc star fd, looks for any of the bracketed deleteds, does a quick test. If there's a process, or if the process looks like it's stuck in a get int call, it does an ls. If that wakes it up, it actually logs and says, hey, I unstuck a directory. If it doesn't, then sometimes we actually assume, you know what, maybe the user actually did this to themselves, because sadly sometimes they do. They'll submit several hundred jobs, get back 80% of the results, and that's really all they need, and they forget about the other jobs, so they delete their working directory, but they leave these other jobs sitting there in these now deleted directories. So I had to actually realize at some point that, you know what, they actually just shot themselves in the foot. So that was a fun one. We've also written, and this isn't a problem, but I wrote an audit to look for any time that either the options were changed in the maps or if the actual mount point was changed, simply because sometimes the change would be made and the reread wasn't going to happen yet, or we weren't sure it was going to happen. So this would essentially just do a quick look, and if there were any mounts, actual NFS mounts that didn't match what was in the map, it would assume that, we should probably unmount this to make sure it gets remounted with the correct options. So that one actually isn't too bad. So then systemd, this is where it gets really fun. So starting testing with SUSE 12, we started to run into some very interesting issues related to time, and it was actually not technically systemd. It's just at the same time the mtab file was changed to a symlink to proc self mounts, which isn't a problem unless you have very big maps like we have. So our initial testing on 12, first off, the automounter, we would boot a machine, it would take several minutes, and then it would come up and the automounter wasn't running, and we would look at the system CTL and the journal CTL, and it would say, the daemon timed out. We'd wondered why it was timing out. So it turned out, because mtab is a file, every single mount that was added to the mount table that as an automounter cache entry, that now on the next, there's a step in the automounter where it makes sure, yes, I'm trying to put a mount on a root file system, not on a non-local file system. So each new mount, it would do this scan. So as you add paths, it gets longer and longer and longer. So just to show how bad it is, before I came here, I actually wrote a script that looped through a bunch of different sizes of map files, and I actually went way beyond even what our map is, just because I was curious. And the output of the table on the next page is the time system CTL start AutoFS with infinite timeout changed. So you can see for a few hundred mounts, it's really not too bad. But as soon as you get up to 5,000 mounts, now you're into several minutes. When you get down to 20 or more, you're several hours. 60,000 is way down there. So then just for readability, I made this next column here is I converted the longer ones. So yeah, now I started a couple of weeks ago, and about a week and a half ago, this one finished. And I had created a loop that was going to go all the way to 100,000. The 70,000 one was up to 60,000 a little over a week ago, and it wasn't done yet. And based on this time, it was not going to be done before I had to leave to come here. So I finally decided, okay, that's enough data. So clearly there was, this is a problem if you have large maps. We're not up at the top, we're not at the bottom, but we are at a significant enough amount of time that it was a pain. So to show what SUSE did, SUSE actually made a patch that took out that extra parse. Yeah, so this last column, all I did was I took, and this machine that I ran this test on was a stock SLES 12, no SP, just the original GA. I took the source RPM that's patched from 12.3, built it on 12, and this is what the new startup times are. So you can see that worst case went from essentially a week to a minute. That's a pretty decent little speed up. So that was probably the best fix we've gotten them as far as 12 is. And as a side note on that, I ran a shell script at the same time those other loops. This was during the 60,000 map run. The first 3 lines it was a while loop that was doing a minute for each, and then the bottom ones were, a second each. The bottom ones were a minute each, but you can see as it got up to huge numbers, it was doing, some of those, and it was weird too, is it could actually speed up and slow down as it got bigger. But, 0.033 mounts per second, that's pretty slow. And since I talked so much about AutoFest, I figured I'd give a couple notes to share that I've got. Logging I find it very interesting that the default logging for AutoMount is none, which gives you essentially nothing. The only logging you get is, hey, I started, and hey, I quit. That's all it logs. We've actually found that we run by default ourselves, we run on verbose. In that setting, it can be noisy if you have big maps like we do, but for the most part, it essentially tells you, hey, I'm trying to mount this path, and either I mounted this path or I did not mount this path. And it will also tell you I'm expiring this path. Debug, they're not joking, it really is for debug. If you turn that on, it multiplies the logging by a factor of about 10. It's extremely noisy. You only want it if you actually are reporting a bug. And so the 2 options we work with are, I mentioned before, the timeout. Another one that actually SUSE helped us find was not a bug of any kind, but we were right, actually, it was a different type of port starvation, and they actually told us, they actually found out for us, when AutoMounter would go to do a mount, it did this step where it would actually do an RPC query to the filer to say, hey, where do you accept your mount commands from? And that would temporarily eat up a TCP socket. So if you just tell it, hey, we always use port 2049, it didn't have to do that anymore. So that saved us from port starvation. Yeah, go ahead. Now, the rest of these that's okay. It's just a transition. For non-AutoMounter related bugs, we've worked with them on. This is not the same one I talked about. This is a different one. This was actually within the last year, I believe, also on 11.4. The engineers had this habit in their workflow of using a directory, doing an rm-rf of that directory, and then recreating that same directory and submitting jobs. Most of us, when we heard that, our first reply was, well, that's dumb. Why are you doing that in NFS? That's not a very smart thing to do. The engineer's answer was, show me an official documentation that says I shouldn't do that. And I can do it on local disk. Why can't I do it in NFS? So we actually, we worked with SUSE, and SUSE found that within a few days, and they actually admitted it was one of the options that they had backported from a newer kernel that someone had made a mistake. And I'm thinking it was a tiny typo, but once that one we had a patch within a couple of days. While working on ARM, my coworker Griff here worked on ARM, and another one of our guys found out when they were using SSSD to talk to our authentication systems, any nested group level directives it was ignoring the directive in the file, and doing any group lookups was extremely slow. LSing file directories was taking a very long time. That was another one that I don't have the details, but Deke did say that was fixed. That was definitely helpful. This was one, actually this was about 6 months ago. It was the xorg x11 lib x11 and xorg x11 lib xcb, where they broke a subset of x11 programs that we did not catch in any of our testing, because unfortunately, I'm sure everyone you can never test everything the engineers or users that you support do. And our stuff all worked fine. We didn't see any bugs. The biggest problem, they had a couple programs crash, but the one that was really obvious was MATLAB would open up and it would just never draw. It would just be a blank window. That's kind of a showstopper. So that was actually, the nice thing was that was a very easy test case. You just had to open up MATLAB. If it drew the screen, you were good. That was one, SUSE fixed that one in less than 2 weeks. And the biggest delay was they didn't have a copy of the version of MATLAB I think it was 2016. And it took their guys' time to get a copy that they could run to test against. But once they got one, they actually fixed it very quickly. There was this kernel backport request related. One of my coworkers was doing GPFS testing. And this actually wasn't a bug. I just thought this was interesting. He did a lot of work back and forth one of the SUSE engineers actually pointed out that he was triggering something bizarre. He always, whenever he did any test scripts, everything he would do a test sync, do a test sync, do a test sync, because he didn't want anything in cache. But something about all of the sync calls he was doing was triggering a bug. When you actually ran real world I/O, it didn't have this problem. He only had it in his testing scripts. So that they were able to point that out to us. The open SSL bug, this was right about the same time when the older methods were deprecated. If anyone who's worked with 11.4 knows that they released that security pack where there's actually an open SSL 1 RPM you can install. But this was actually in the actual Perl module that we unfortunately had used across hundreds and hundreds of different engineering workflows. And there was no simple fix. So the SUSE engineers actually gave us a patch to the Perl itself, not the module. It was actually something they did in the main Perl binary that fixed this. That was kind of going way above and beyond. Our guys went and rebuilt this Perl in AFS for us real quick that all these scripts called, and that solved that problem. So here, this was another interesting, not a bug. This is one of the things that SUSE actually solves lots of problems for us that aren't even bugs that SUSE had anything to do with. We had this was when this was newly, but this was 3-4 years ago now, our internal imaging tool. There was a step where JSON was parsed into a format you could grep. It was for people doing shell scripts instead of wanting to actually read the JSON. But it was a shell script that did a Perl-X call that used the JSON module. And it turned out that the JSON module that the imaging group included was, I don't remember the exact, it was something like 0.314 instead of 0.315. And when we finally bumped that little change, the installs went from taking over an hour to 20 minutes. So that saved us a lot of time. And I actually already mentioned this one with the option is, this is the details where when the auto mounter goes to do the mount, it does that RPC bind call. That was causing port starvation. So if you just set that default port, it doesn't have to do that query anymore. So yeah, go next one. This was another fun. This was actually a bug, and SUSE had nothing to do with it, but they actually found it and were able to point out the fix. So while SUSE doesn't technically support OpenAFS, they've always given us best effort. And there was a version, this was actually on SLES 10, SP3. There was a bug with, I believe it was OpenAFS 1.4.12, where if the cache that was on disk and was on ext3, something specific would happen that would cause the AFS daemon to just completely lock up. It was a complete denial of service. When SUSE found out the cause, they gave it to us, and we gave it to Synomines, a company you can purchase support for Open. They do basically contracted OpenAFS support. They actually found out that this was actually a massive security bug, because anyone that could touch the box could run a simple command and lock up the AFS daemon on any machine that had this bug. So they rushed that fix out and got it fixed before anybody else found it. We're very good at finding bugs that nobody else runs into. So we got that one fixed. No one else ran into it but us. And then more systemd issues were actually, and this actually loops back to the mtab, a little bit of the mtab actually, and some of systemd itself. When we first would go to shut down or reboot a system, it would take 20 or 30 minutes at least, if not more, because there were essentially code in systemd and in the shutdown, the drag cut shutdown module that essentially did while and then while do, and it basically said like unmount path and then redirected proc mounts into it, and it didn't care what the file system was, it wanted to unmount it. We didn't care about the auto mounter file system entries. They're caches. They aren't really mounted in a normal sense. So I actually patched systemd itself. It was ugly. I'm not a C coder, so it wasn't very good. But I found a way to patch it and the shutdown as a way to just get through testing, because it was so painful sitting there watching these machines shut down. But SUSE actually came up with a much better fix, and I'm sure it went up the stack at this point. And then Actually, go back for just a sec. Was that the same? Yeah, that's all right. Yeah, you're not used to it. Oh, yeah, Draca, basically this is the mtab file problem again. Anytime you do an RPM install or upgrade, if it called Draca to do the make init.rd call again, same problem. Parse over that file over and over and over and over again. If you actually strace it, you'll see it reads proc mounts again and again and again. I don't know why it has to do it multiple times, but it would. So same kind of thing. They did a fix that basically told it, hey, if it's file type AutoFS, just ignore it. And that fixed that problem. So now it's, you know, Draca runs in seconds like it should. And they gave us a PTF fix for that in less than 2 days. And then this last slide I actually threw in, I had to take a picture of it when he put it up yesterday, because that first point he made about the vision, you know, working with the customers to help us to actually innovate and compete is exactly what SUSE has been doing for us. So we've been extremely happy to be working with SUSE for a long time now, and it's been a great partnership. So, and with that, that's pretty much all I've got. So if you have any questions, or
I have one thing to add. So the Etsy Untapped stuff, right, is where I'm at in the company, I have to deal with all the other Linux distros as well. And that affected everything that ran systemd. And all of them were broke for a really, really long time. SUSE fixed it. SUSE pushed it upstream. Then it went and made, you know, all the other distros much better. And then my life became a lot better, because then I didn't have to worry about the orange distro or the red distro not being able to parse huge auto-mount paths or anything else. And that's just, personally, that was a great thing that SUSE did for me to make my life way better.
Yeah, that's one of the things is all of the pain we've gone through that SUSE has fixed for us has benefited everybody. So that's another positive. They share everything upstream. So, well, if that's it. Thanks.